It's all you now.
Thank you so much. All right, we're the last session, I suppose, on main stage, Graphiant and Valmont. We're going to talk about how things have been done. We're going to talk about some real situations and use cases and stories, the Valmont and Graphiant story. We're going to stay simple, make it easy to consume what we're going to talk about, and you're going to leave this session, have some lunch, enjoy this rainy weather in Dallas, and figure out how we're going to fly out of here today. So, with that, I'm Ali Sheikh. I'm the Chief Product Officer for Graphiant. What that usually means is that when the sales guys go sell something, I have to figure out how to make it real. And with me is Jason Foix with Valmont. Jason, why don't you introduce yourself?
Jason Foix. I've been with Valmont for 20 years. For me, Air Force veteran, father of two, married to a wonderful and patient wife. I've done a lot of different things technology-wise in my career, electronic tech in the Air Force, contractor, government contractor after that, healthcare, from an IT perspective, healthcare, transportation, and manufacturing.
Jason's done a lot. Jason has done a lot.
Yeah, diverse. So it's been enjoyable, fun, always learning, which is fantastic too. I mean, otherwise, if you're in the corner crying, it's just not worth it. So, yeah, definitely.
So what we wanted to talk to you guys about was, rather than do like a vendor pitch and try and tell you all of these things, we wanted to talk about what our journey with Valmont had been and what Valmont looks to solve as well, right? Like talk about who is Valmont, what Valmont does. So what I wanted to first get into, because not everyone might know Valmont, is Jason, tell us about Valmont. What do you guys do? What problems do you solve? Where are you all over the world?
All over the world. We are a global company. We're on every continent except for Antarctica. We're in, I'm not going to say every country, but we're in a lot of different countries, South America, with Brazil, Argentina. So there is an interconnect that needs to be done, and that is key. We've got two divisions that are agriculture and infrastructure. Agriculture division is crop management, irrigation. We're the leader for center pivot irrigation systems. Back to flying. So when you do leave and you're in the plane, you look down onto the ground. If you see the square areas and then there's a circle where it's all green, that's our pivots doing that work. So we also have infrastructure systems, poles, light poles, basic stuff. But also smart poles. If you step outside in the atrium, you'll see some across the street.
And what it shows, right, is Valmont is fundamental infrastructure in the country that sometimes people may not know about. When you think about agriculture, when you think about light poles, physical infrastructure that makes up our country's infrastructure, Valmont is a huge part of that.
Yeah, absolutely.
And
power substations.
It kind of speaks to Valmont's journey itself. I mean, why don't you tell us about Valmont itself as where you started at?
So that perfect picture right there, one of the originals. Valmont started, created 1946, 1947. Bob Doherty was a founder. I know when I started 20 years ago, it was just under $1 billion company, 250 million revenue. And we're talking 4.3 billion now. I think at the time we started with 80 sites that were connected, but not nearly all of them are manufacturing sites. You got some admin sites and whatnot, and it's just grown, and it's been a magnificent growth. So it's been enjoyable.
And I think what we start to see, right, is the growth of Valmont is kind of representative of what's happening to pretty much every company in the world, which is to say everyone is a tech company. Everyone is having to invest in technology and develop technology and continue to modernize. So it's not just the tech vendors or the cloud vendors or the AI vendors. Everyone has to invest in technology and develop and continue to grow.
Yep.
So even when we discuss Valmont isn't just agriculture and infrastructure. Valmont is itself a technology company.
Absolutely. If you just focus on the pivot side, it looks like it's a simple sprinkler in all purposes, but there's so much more that's on it. It can detect whether or not it needs to add water, it needs to irrigate, herbicide, pesticide. It has the ability to analyze what it's going over to take care of that. The image there is solar. We've got a solar division too, looking into the future, green, and the next step. Well, you got to get the power off of it, but you also have to manage it and maintain it too, and they all have to adjust and go towards the sun. So they're highly usable in that fashion. Smart poles is another image in there. We're really getting a lot of traction with that, and a smart pole can have tons of different sensors onto it. So you've got cameras, TVs, so you can post a bulletin, like if you're at the park or at the mall. So there's huge things to include lighting on a pole.
And I think that's so compelling, right? We'll look at manufacturing, we'll look at healthcare, retail, and in a way we can start to begin to really look at every company and say, at a certain point, they became a technology company. They started investing. They started building new mechanisms. They started first talking to vendors and then writing their own automations and software. And there's so much data that is being generated by all these different divisions that has to be used in some shape or form.
Yeah, absolutely. Absolutely. There's a ton of data. The amount of available data from the infrastructure systems, it's got to go somewhere. And it's happening real time, and you want to react real time. So yeah, absolutely. Pivot systems, same way. Farmers, they own thousands of acres. They're not going to travel from one place to another. They don't have that time. You don't necessarily have that staff. You got to get an alert or notification or something on a problem. So the system allows that to happen.
And as we see, right, it's why we chose the title of this session to be a certain way. It's the nature of our infrastructure is changing. Our technology is being developed everywhere, and the data sets need to move. So being static, like building static topologies and static networks, won't really fly anymore. Right? The nature of the network is going to be quite critical in transporting this data. And I know AI is overhanging us, and we're going to talk about them in some shape or form throughout. But we really have to be cognizant of how does this data going to be transported so that it can be processed. And in order to meet those demands, it turns into the question of what is the kind of network you're looking for, and why do these things matter?
Definitely. Scalability. If you had to guess how many pivots that are out there, how many do you think?
Thousands?
Hundreds of thousands. Yeah.
Hundreds of thousands.
I mean, and that's just my company. That's not counting the other, lesser, whatever, other companies that are out there. But yeah, there are a ton of them. So you've got to get the data somewhere, somehow, so it can be processed, it can be analyzed, reacted to. So scalability is one, and it has to be. And regionally scalable too. We're global. So, there may be drought in one area where things are being reduced. There may be where, you have the floods in South America where things change. And it's not just what it's doing, but now you have to have service issues with those locations and such. So there's that scalability is one. Flexibility, I want to be able to do, everybody says it, I want to be able to do what I want, where I want, and how I want. You got to have that flexibility to leverage those at your best assets for your business. And then the agility, it's kind of similar for us on the flexibility aspect. I want to be able to do it quickly. If we see our markets needing to change, and I'm not an irrigation or an infrastructure guy from a business perspective. I'm just a network nerd, and I manage the corporate aspect. So that's kind of the background for me. But we're a business partner, and we're helping the business. It's really kicked in a lot as of late with our relationship with Graphiant, and a realization for that too.
And then that really started to turn into what were the problems that we were trying to tackle, right? So we're still networking folks, looking at data, looking at AI, and trying to see how it's all going to come together. But what are the problems we're actually trying to solve? And why is it requiring us to reimagine the network, make it so that we can transport the data and solve these use cases? So the engagement with Valmont became around how do we tackle 3 particular business areas that are important to Valmont, that they specialize in, that drives a huge amount of business for them, and they're continuing to grow in that. How do we transport data for it? How do we analyze that? How do we make that network more adaptive for those scenarios? And so, Jason, tell us a little bit about what's happening in each of these, right? You've got 3 really, really cool images.
Yep.
What are you doing with each of these?
So they all have data. They all got to get it somewhere, and they're in different regions. So we talked about the pivots quite a bit. I know it's our history, it's our origin story, but we have relationships. We actually have different technology companies within our own company that do that data. They take the data, they analyze it, and they have connectivity with carriers to get that data privately from their systems into whatever their infrastructure is. It's a bit difficult. A couple weeks ago, we're standing up a VPN tunnel that's statically set, and there's no flexibility in, well, what happens if within that infrastructure. So you're leveraging that. The agricultural society or sector, they're not in the most populous place for a purpose. So you've got to think about, how do you get that data there? Is it cellular? Is it, Starlink and satellites? So we're staying flexible in that aspect and being able to adapt to what can we leverage and who do we leverage to help us get the data from A to Z. Smart pole, that one's typically an easier path because you're typically in cities. You're where internet services are fairly readily available. But there's still a lot of stuff and a lot of data that comes off of a smart pole.
And I think the nature of the data becomes quite different, right?
Yes.
Your agriculture facilities are really remote, and we need to give them reliable connectivity to transport sizable amount of data. The smart poles, they're fairly pervasive in areas where there's a lot of connectivity, but that data needs to go in a lot of different directions.
Yeah.
Right? You've got sensors for different purposes. You've got EMS, public safety, all kinds of sensor data that may need to go to different entities.
Securely.
Sliced
securely, so whoever's authorized wants the data from a camera, say on the corner pole, there was a car accident or something of that nature, you want to make sure that you can hand that off to who wants it or who's authorized to use it securely.
And so my network type, right, for the agriculture space is different. For the smart pole environment is different again. That needs to dynamically determine which end user it might need to go to, which partner it might need to go to. And then you get to the more interesting and fun section of the drone space.
The drones.
And tell them a little bit about the Air Force.
Valmont Air Force is kind of the nickname we've given them, and we do have a set of drone operators. And those drones are massive drones. They are huge. But we use them to quickly and safely inspect the infrastructures that we have. One of the infrastructures I didn't mention before, but Ali nailed it, was not just light poles. They're relatively simple, but we've got electrical substations that we produce for too, or even wind energy. So that's a monstrous system, and it's not. You can't just shut down a power facility in order to have a couple of guys up there and checking, is there a crack, or is it rusting, or is the pole somehow being damaged in a way. So we're able to deploy drones and in real time then take the images that they're actually scanning, and there's a lot of scans, a lot of pictures. It accumulates a lot of data, and then send that back real time to an aggregator or back to our repository, and then package that up for the customer and say, of the 50 systems that we checked for you, here's what we see needs to be remediated.
And I think this is what we want to highlight, is the use cases that need to be tackled to continue to develop and evolve America's infrastructure. A lot of things are evolving in lots of different areas, and businesses like Valmont are driving that. But it's data-based, right? Data needs to move in a lot of different directions so we can analyze and process that.
Yep.
But the networks we've built in the past have been fairly static. We built networks around, we're going to have a bunch of people in an office and a bunch of applications in the data center. And then we got cloud in the mix, and there's a bunch of apps in the cloud, but people are still in the offices. And then we have a pandemic and a bunch of people move and work from home. Okay, but we're still building the network for people in some fixed locations and a bunch of apps and data in some fixed locations. But now I have these different types of infrastructure generating massive amounts of data that needs to be transported on a network that needs to adapt. And so that if it needs to go to an AI workload here or there, who's going to process it? Where are they going to process it? I don't want to have to redesign the whole network every time. But our challenge was that we had that problem.
Yeah.
And you tell us what you felt.
So when I started 20 years ago, we were using Frame. So not sure how many network guys are out here, but Frame and Layer was great. But small bandwidths, life has changed. We've all evolved. So that's where we started. And then shortly after that, we moved to an MPLS environment. We had two regionally. We had one provider, and they were both managed services. And that's a whole nother layer of complexity and sometimes difficulty with the managed aspect. But we had two providers, one for the Americas, North and South, and then another provider for the rest of the world. And they were stable, they were good, they were expensive.
No ill will towards MPLS, but it takes a long time to get MPLS anywhere.
Yes, depending on the country. Depending on the country, we had some where it would be, we'll get you that in 180 days. I mean, and that's 180 doesn't seem like that much, but when you then turn that into months, you're saying 6 months. I mean, that's a long time. When I can go and ask Comcast, mind you, this was quite a while ago, but you can go and ask Comcast or some other broadband provider to give me an internet circuit in 3 days at this location. So very difficult. It took a long time to get things done. It was expensive, but it was good at connecting site to site and whatnot. Some of the biggest challenges are if you intermix them, where you intermix them, you're going to have that interconnect, and then that can get very messy and be problematic. And we actually had that in two different places, one in Sydney and one in North America, and it gets very messy. So you've got to manage that.
And then in order to tackle that, we started going down a different journey because you're not new to SD-WAN.
Oh, no, not at all. No, we've been using SD-WAN.
We went down the SD-WAN road too.
Yep.
And we looked through how do you transform from MPLS to SD-WAN, and you guys were one of the earliest adopters in the space. Again, thinking and imagining Valmont as a tech company, leading the way in adopting newer technologies.
Yeah.
You were one of the first ones. And tell me, how did it work for you, and where did you start running into problems?
It worked well, it has worked well, we're still using it. We were original Viptela customers, Cisco SD-WAN now. Flexible, cheap commodity internet, gets me network connectivity anywhere, anytime, how I want. If I need a broadband circuit here or DIA circuit there, works great. It is expensive because of you're beholden to the manufacturer's hardware, their software platform, their interconnects if you leverage them somehow within the cloud or whatever. So it does become expensive. Your contracts, you then have to worry about those as well, and that's an expensive journey. And depending on who you partner with, it will depend on whether or not your feature capabilities will happen faster at the speed you wish them to happen, which doesn't seem like a lot, but sometimes it can be. And we're not just talking, lower layer stuff like SNMP or LLDP or anything like that. Just talking about other app development and steering a application-aware routing, to coin somebody's phrase, stuff like that. You sometimes will be stagnated and waiting for them because they're larger. You're not really a partner with them. You're the customer, and that's a big challenge.
And I think that is when, from a journey standpoint, right? Valmont knew that they were going in this direction of all these new technology use cases, heavy amounts of data that needs to be transported. You have these cost challenges, this time to delivery. And we know AI was, at that point in time when this whole thing started, AI wasn't in the hype cycle that it is now.
Yeah.
But now it's like, okay, we have a lot of data, we have all these use cases. Guess we have to apply AI to it in some shape or form. How do we move that data?
Yep.
So this is when, from a Graphiant standpoint as well, we started we found each other in a way. Graphiant was building out this infrastructure, looking at how do we make topology restriction-free networks. Data can move in any direction. I don't want to have to redesign route tables and VRFs and tunnels and VPNs every single time I onboard a new partner, or I have some new AI project that I start up and I need to sift data here to there. Localization became super important around in-country restrictions. This data can't leave country X, even if you want to process it. Doesn't matter if AWS has great resources, you can't make it leave the country.
Yep.
All those kinds of challenges meant Graphiant wanted to tackle this topology-free infrastructure. But we didn't want to do it in isolation. So like, you don't want to just be writing code and building something without knowing if it actually solves someone's problems. And so we reached out to Valmont, but Jason, why'd you reach out to us?
So the partnership, co-development part is a big thing. It's huge. It's great to be a part of. It's fun, so to speak, to be on that new piece. But when you're actually building it for not just you, I mean, networking is networking, but knowing that others can leverage it as well and gain benefit from it, and knowing that it's solving the right problem with a good and the right solution, that's key. But yeah, the co-development's great. Situation happened Monday. I sent an email off to my SE, Phil, fantastic guy, and I'm like, hey, I got this problem. I'm not exactly sure why. And it's an ARP thing, so it's just a network stuff, not a big deal. But there wasn't, we get on a call, and I thought the box had been rebooted. It hadn't. We rebooted it and it fixed it. But then it did bring to point, well, hey, what if I wanted just to clear the ARP cache without having to do a reboot? What if I just wanted to do this? And his statement was, hang on a second, I'll start writing up a request to get that in. And it hasn't been done yet, but because it was just Monday, but within a matter of weeks.
I saw it Monday afternoon. It was in the queue by Tuesday.
Yeah.
And this is the fun part of it, right? Networking especially, right? As much as new cool stuff starts showing up, network has the unfortunate burden of we have to support everything that has ever existed.
Yes.
Right? If an application was written in 1992, we're still supporting it somewhere. We still have to write firewall rules for NetBIOS. I don't even know where that exists anywhere, but you still have that in the firewall stack. Deny this thing. So network always has to deal with those kinds of things. But the way, as Graphiant, we approached this was the problem we're focused on, the big problem is data networks will be built, not user or application networks. And those networks mean that you can't have giant route tables in the provider environment. You can't have tunnels terminating in 9,000 different places. You can't have to do an IP route lookup every hop by hop by hop. That can't be the way to do this. We have to push that logic to the edge, and the edge should be able to make those determinations, but we'll still have to support everything that's come before. And so when suddenly there's an ARP issue, which, I mean, when has ARP changed in the longest time? Like, okay, still have to tackle those kinds of things.
Violator, sorry. It happens.
Like, sometimes we get there have been times when you'll say, hey, I need this thing in SNMP. I'm like, all right,
yes,
turning it around.
That is correct.
Okay, well, we've still got SNMP there.
You still got to support me on that one, sorry. But to your point of the route table aspect, that is one thing MPLS taught us, being managed to a certain degree, was you just kind of have to learn to let some things go, and that was one of them. It's not because you don't want to let it go. You still need to know it. You still need to be intelligent about it. But it's sometimes you don't have to care about it. Just as long as you know the partner's trusted, right, and you have a good relationship, and you can get your information from where you need to where, from where you are to where it needs to go. That is huge. That's a big thing. And that's, like I said, one learning thing from MPLS that has been carried on through both SDWAN and our Graphiant experience.
And this, for those who want to know, right, Valmont was very significant in influencing what happened to Graphiant as we developed and evolved, right? All of these things that you'd highlighted, we incorporated as part of the building cycle, even the business aspect. You were unhappy with about things around support contracts and licenses and license fees and different license tiers. We got rid of all of them. We changed it to the model so that when you use it, when you consume the service, then you pay for it. Otherwise, you don't.
Yep.
So it was important to get that input that people who lead the way wanted that kind of transformation. In terms of security, we wanted to make sure that we build encryption all the way through, end-to-end encryption, and even think about the sort of post-quantum space that's headed our way. Because very quickly, the whole conversation around AI and data is also very quickly going to become about, is that data encrypted in a way that no one else is going to be able to break it and train their LLM? So those are fairly tightly coupled things that's going to be very important. And working with you guys around the agility and performance, right?
Yeah.
How do we deploy? Where do we deploy? How quickly can we turn things up?
Yep.
So I think from your point of view, Jason, right, specifically on the performance side, I could talk about the performance on the platform side and the services we've built, but your experience of performance, what were you looking for? What matters to you?
So we've got, and this is totally on the network side team, not about the business aspect, but we've got, we use a NAC for some of our, well, actually 802.1x NAC down to the wire. And we've got databases across the globe for all of our sites, and they do a sync. If that latency is above 200 milliseconds from Omaha to Sydney, Australia, they start to break apart. And the only way to fix that would then be to stand up a whole system in each region. And that just isn't really viable because you have to start duplicating all your rule sets. So that's a very focused for my team and for me to have to handle for that. Performance across the network, though, is not an issue for us and what we're doing. With the Graphiant platform, it's functional, it's working. I haven't had that issue. It's agile on the fact of, it's global. So that's fantastic. Not everybody can say that. I mean, I know we're a use case of a global company, and not everybody is, but that's a huge impact. That's a huge benefit for us. And
that was something, right? We learned from the SD-WAN experience was you could build an overlay, but you couldn't do anything about the underlay. You had Thousand Eyes, Kentic, SolarWinds. You could have all the monitoring platforms in the universe, but you couldn't influence the underlay. If something happened, you were out. You couldn't reroute the traffic inside the internet backbone. SD-WAN would show it to you, but then what? You have a BGP poisoning attack, AWS East takes a hit, everyone takes a hit. Everyone's controller goes down, and then you may as well go home for the day as a world. Wait for AWS to come back.
No, that's totally true. And being global, we've had some bizarre problems where Office in Thailand can't connect to an app that they're trying to use out of Valley, or it's very intermittent, and come to find out that it was an NNI somewhere. So it wasn't your end partners that you have your actual contracts with that you can influence and get things fixed. It was somewhere in the middle. Well, how long is that going to take to get fixed? I mean,
exactly.
Hopefully there's enough complaining from other customers that somebody's like, you need to look at this. And then when it does get fixed, how are you notified? You don't. So having to know that that middle mile aspect is no longer a question as to how it's going to perform, that part is a huge burden. We knew the internet through SD-WAN. We knew that was some possible problems, but we've probably had that issue happen to us 5 times, 6 times, and it takes weeks to resolve itself.
And this is where, as we think about the lead up, right, it's the networks have to be dynamic. They have to adapt on their own. They have to be oriented around data. And when you consume data, I shouldn't have to build a tunnel or a network or an overlay every time. The overlay and underlay should be tightly understanding of each other so they can influence one another, so that you can consume network truly as a service, not build tunnels, not build licenses. Because then we're really talking about what all of this leads to. And that, I think, is, we're gonna wrap this up because we're gonna talk about AI in this context, because we wanted to make sure we weren't preaching to the choir and just pushing AI for the sake of it, right? So, Jason, what do you think about that? And give me one last, and we'll close with that.
It's a repeat that I've said already, for us in the future, it's how can we get that data to where it needs to go securely and then offer it to those that need it or want it. For us, that's the next step. It's eliminating those static components and being more flexible. That's the one thing for me is I don't like any one single point of failure. And if it can be dynamic and do it, I mean, that's what the internet touts. If it can do it on its own and maneuver around, accurately and efficiently, let's let it. And yeah, that is a definite value add for us in the future plan.
So thank you, Jason, for your time here, and thank you, ONUG, for having us here. I think you'll see we're very, very thoughtful about, we've had to build the network in such a way that it can account for AI and the data movements rather than try and jam it all over the place. We're all networkers here. We're going to be building networks for a long time, and we have to think about how we support them in a dynamic, non-static way. So thank you all for joining us today.
Thank you.